Hello friends, welcome back to my channel Quality Talks. In the last video, we discussed correlation analysis where we calculated coefficient of correlation and coefficient of determination. We worked on a practical case study to understand the relationship between flow rate as output Y and three input variables injection pressure P, nozzle diameter D and fuel temperature T. From our analysis, we observed that flow rate has a strong positive correlation with injection pressure and nozzle diameter, while it shows a weak correlation with fuel temperature. This clearly confirms that there is a relationship between the inputs and output. However, correlation alone cannot help us predict the exact value of flow rate for a given set of input conditions. So the question is, how do we predict the output when input values change? This is where regression analysis comes into the picture. Regression helps us build a mathematical model that establishes a relationship between the output Y and multiple input X. Using regression, we can develop an equation like FR is equal to B0 plus V1P plus B2D plus B3T. This equation enables us predict flow rate for different value of pressure, diameter and temperature, understand the quantitative impact of each input variable, and it helps us to make data driven decision and forecast. In simple terms, while correlation tells us whenever a relationship exists, regression tells us how to use that relationship for prediction and decision making. As discussed in the last video, Mr. Problem Solver collected flow rate FR data at different value of input parameters. Those are injection pressure P, nozzle diameter D and fuel temperature T. In our previous video, we performed a correlation analysis on this dataset. We found that injection pressure and nozzle diameter have a strong positive correlation with flow rate, whereas fuel temperature shows only a weak correlation. Now comes the critical question: should we include fuel temperature in our regression model? Although the correlation analysis shows that fuel temperature has only a weak correlation with flow rate, correlation alone is not enough to make these decisions. Regression analysis will help us determine whether fuel temperature adds value to the model. So let's move ahead and perform the regression analysis to understand the true impact of each input variable. For performing regression analysis in Microsoft Excel, we need to go for data, and then in data we have to go for data analysis. In data analysis, we can see this type of window and we can find out regression here. Once you click the regression, this dialog box will appear. In this dialog box, first select the input Y range, which is flow rate in our case. Make sure you select all the observed flow rate values. Next, select the input X range. Since our model has three input variables, pressure P, diameter D and temperature T, select all three columns along with all their observed values. Now let's look at the checkboxes. The first one is the label checkbox. Since the data we selected includes column headers, FR for flow rate, P for pressure D for diameter, and T for temperature. Excel need to know that these are labels, not data values. Therefore, make sure to check the labels checkbox. The next option is the confidence level. Check this box if you want Excel to calculate confidence interval for the regression coefficients. The default value is 95%, which means we can be 95% confident that the true coefficient lies within the calculated interval. In most cases, the default value of 95% is recommended, so we will leave it unchanged. Now let's understand the checkbox constant is 0. Our regression equation is flow rate Fr is equal to B0 plus B1P plus B2D plus B3T, whereas V0 is the intercept. If we select the constant is 0 checkbox, we are forcing the intercept to be 0. This means the model assumes that when pressure, diameter and temperature are all 0, the flow rate will be 0. Although it is true that if the diameter is 0, there can be no flow. The regression intercept is not based on the diameter alone. It assumes that all predictor variables are 0 simultaneously. In most practical situations, this combination is either unrealistic or out of the range of our data. Therefore, we generally leave the constant is 0 checkbox unchecked, allowing Excel to estimate the intercept from the data. So far, we have covered all the inputs required for regression analysis. We entered the Y range and X range, and we also discussed each of the available checkboxes in detail, understanding their purpose and when they should be used. Now, let's discuss the output options. Excel allows us to display the regression result in 3 different ways. In the same worksheet, in a new worksheet within the current workbook, or in an entirely new workbook. For this example, we will choose the new worksheet ply option so that the output is neatly organized on a separate worksheet. In output, you can get the information about the residuals. We will discuss more about the residuals in coming videos. You can have residuals, standard residuals, residual plots and line fit plots in your output. At the same time, you can get normal probability plots in the output. By checking all the boxes, now we can click OK for the output. This is the regression output that we will be analyzing. In the next video, we will go through each section of this output in detail and learn how to interpret these results. Until then, stay connected. If you found this video helpful, please subscribe to the channel and share your valuable feedback in the comments. Your support and suggestions help me create even better content. Thank you for watching. See you in the next video.